Hello and welcome, and in this video we're going to continue graphing piecewise functions. So if you haven't seen my intro video, make sure you go back and watch that, because we're just going to dive right in, because there's so many different examples of piecewise functions with all the different types of sub-functions you can have, the different types of constraints, where they can exist, that I want to go over a couple of more examples. So I'm going to jump right in here, and I'm going to graph this first part right here. This is telling us to graph y equals negative 1/2 x plus 2 when x is in between -6 and +2. So I'm going to go ahead and graph this. Now, what I do see some people do, and I said in the last video, like, I don't prefer it, but I'll just go ahead and show an example. Some people like to kind of draw lines where it's going to start and stop. This said it was in between -6 and +2, so that's why I'm drawing lines there. If this helps you, feel free to use these, but make sure you erase them once you have graphed that part of the piecewise correctly, okay? Because if you leave those lines in, that's technically incorrect, okay? So let's go ahead and graph this. So I'm going to graph y equals negative 1/2 x plus 2 and get rid of what I don't need, okay? Slope of negative 1/2, so down 1, right 2, y-intercept of 2. So let's go ahead and graph this. Okay, so those are the points that are going to be kept for this particular line, but I have to pay attention and notice that at -6 it is not or equal to, so that is actually going to be an open circle. So let me end this with an open circle when x is -6, and when x is +2 it is or equal to, so we are going to leave that closed. So this would be our line. So as you can see there, since there was a defined starting and stopping point, that's why we have this like line segment look, okay? Now the next part is a little bit different. This is saying graph y equals 3 when x is greater than 4. Well, this is just a horizontal line with no slope and a y-intercept of 3. And once again, I'll go ahead and use a line to show where it starts and stops. Okay, so there would be our line of y equals 3 when x is greater than 4, but I need to make an adjustment here because it does not say x greater than or equal to, it's strictly greater than. I actually have to make that point an open circle. So I'm going to make that an open circle, and there is my line. So that would actually be my graph. So notice there is kind of gaps here in between the sections of the piecewise, and that's totally okay. Some piecewise functions will have that. So that would be that particular graph. Let's take a look at another example. All right, so we have a new piecewise here. Notice this has 3 subfunctions, so it's going to have 3 pieces to the graph, okay? So this first subfunction, this is asking me to graph y equals 2x plus 6 when n is less than or equal to -2. So let's go ahead and graph this. Now, I'm not going to use the lines like I did in the previous one. If you want to, feel free, continue to do that. I'm going to go ahead and graph the whole line, and I like to just erase what I don't need. So let me go ahead and do that. We have a slope of 2 and a y-intercept of 6. Let's graph it. So these would be all the points plotted, but I only exist when x is less than or equal to -2, so that's to the left of -2 for x. So everything to the right of x is -2 is we're going to get rid of that, and now it is or equal to -2, so that is going to stay as a nice solid point, and we're going to connect these and continue forever in the left-hand direction because there was not a defined starting and stopping point. This does definitively stop when x is -2, but it's going to continue forever to the left-hand direction, okay? Now the next piece is going to be y equals -x minus 1 when x is in between -2 and +3. All right, so I'm going to go ahead and graph all of these points. Okay, so those are all the points, but this only exists when x is in between -2 and +3, so I'm going to have to get rid of a bunch of these. So I'm getting rid of all of those ones. X is -2 there, x is +3 here, so I'm getting rid of these ones, okay? And when x is -2, it is not or equal to, so I'm actually going to have to change this to a open circle. So let me go ahead and do that. So I should change that to an open circle, but it is or equal to when x is 3, so that's going to stay nice and close. And I'm going to go ahead and connect those points, and that is my second piece of the graph. Let me fix up the first one. I accidentally erased it a little bit. All right, so that is our second subfunction graph. Now the last one is y equals x when x is greater than or equal to 3. So a slope of 1 and a y-intercept of 0. So let's go ahead and graph that. Okay, so I actually stopped plotting because I don't feel like plotting the rest of those because I know it's not going to exist in some of those areas. So this is only when x is greater than or equal to 3. So I'm definitely getting rid of all of these. I'm getting rid of these ones. I start when x is positive 3, and it is or equal to, so that is going to stay a nice closed point, and I'm going to connect these forever to the right because the graph does exist there because it is x greater than or equal to 3, which is when we are moving to the right, okay? And that would be our piecewise graph, okay? Got a little bit of time. I'm going to cover one more example, and this one's going to be a little weird. Just be aware, it is going to be a bit different, but this might be something that you come across. All right, so this is the last example that I want to go over, and this is a particularly kind of different one. Not difficult, but just different, okay? So this is y equals, we're going to be graphing y equals negative 3/4 x minus 2 when x is not equal to 4, okay? Now that looks strange. A way you can think about this is we're graphing this line when x is less than 4 and when x is greater than 4, just not when x is 4. So I'm going to plot all these points the exact same way. Let me go ahead and do that. All right, so this would be the line graph if there was no constraint, okay? However, this graph does not exist when x is 4. So it exists when x is when x is less than 4 and when x is greater than 4, just not when x is 4. So the way we can handle that is literally by just erasing that one point and instead using an open circle to show, hey, it exists on either side of this point. It just doesn't exist here at this specific point, okay? So that would be the first one graphed. Now the second one is I'm graphing y equals 7 when x is equal to 4. So that's the only time I'm graphing this. Now this would just be a perfectly horizontal line. This would be a perfectly horizontal line. Like if I wanted to, I can go ahead and graph that terribly, okay? But I would end up having to get rid of all of it except when x is 4. So when x is 4, y is 7, that's the point. That is the only piece that is going to stay from that particular subfunction, okay? I am going to get rid of the rest of it because it does not exist. This function does not exist unless x is 4. So that would be the second subfunction graphed, okay? And I know it looks strange, but if you're thinking about it this way, you're literally just plotting the point. Okay, well, x is 4. X is 4. Oh, let me do a pen. That would be cool. X is 4, plug in 4, and we would just end up getting 7. So it's literally just the point 4, 7, okay? And that is graphing piecewise functions, okay? If there's any questions, please feel free to let me know. I hope this video was helpful. In the next coming videos, we're going to be taking a look at some application problems, maybe some evaluating problems, and then we're going to be moving on to transformations and absolute functions.